Hey there! Welcome back to our channel, where we explore the fascinating world of chemistry. Today, we have something really special lined up for you, the quantum mechanical model of the atom. So grab a cup of coffee and get ready to dive into the intriguing world of subatomic particles and quantum theory. Now, let's start by understanding what the quantum mechanical model of the atom is all about. Developed in the early 20th century, this model revolutionized our understanding of the fundamental building blocks of matter. It replaced the earlier models, such as the Bohr model, which couldn't fully explain certain behaviors observed in atoms. So, what makes the quantum mechanical model so special? Well, it incorporates the principles of quantum mechanics, a branch of physics that deals with phenomena on extremely small scales, like atoms and subatomic particles. According to this model, electrons don't orbit the nucleus in neat, fixed paths like planets around the sun. Rather, they exist in a cloud-like region around the nucleus, known as an electron cloud or an orbital. Wait, but what exactly is an orbital? An orbital is a three-dimensional region around the nucleus where an electron is likely to be found. It's not a physical object, but rather a representation of the electron's probable location. Each orbital can hold a maximum of 2 electrons, and they are classified into different types based on their shape, size, and orientation. Now, let's discuss the principal quantum number, denoted by n, which plays a crucial role in the quantum mechanical model. It defines the energy level or shell in which an electron resides. As the value of n increases, the energy level of the electron also increases, and it moves farther away from the nucleus. Each energy level can contain a maximum number of electrons. The first energy level, designated as n equals 1, can hold a maximum of 2 electrons. The second level, n equals 2, can hold up to 8 electrons, while the third level, n equals 3, can accommodate a maximum of 18 electrons. Beyond this, it gets a bit more complex, as the higher energy levels have different subshells and orbitals. Speaking of subshells, let's break down the different types. Each energy level is made up of subshells, which are denoted by letters like S, P, D, and F. The S subshell is the simplest and can hold a maximum of 2 electrons. The P subshell can hold up to 6 electrons, the D subshell can hold a maximum of 10 electrons, and the F subshell can hold a maximum of 14 electrons. Now, you might be wondering, how do electrons fill up these energy levels, subshells, and orbitals? Well, that's where the concept of electron configuration comes into play. The electron configuration is a way to represent how electrons are distributed within an atom's energy levels, subshells, and orbitals. To determine the electron configuration of an atom, we follow a set of rules called the Aufbau principle, the Pauli exclusion principle, and Hund's rule. The Aufbau principle states that electrons fill the lowest energy levels first before moving to the higher ones. The Pauli exclusion principle states that no 2 electrons in an atom can have the same set of 4 quantum numbers, which include the principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Finally, Hund's rule states that electrons prefer to occupy different orbitals within the same subshell rather than pairing up. Now, let's not forget about the spin of electrons. Each electron has a property called spin, which can either be up or down. According to the Pauli exclusion principle, no 2 electrons in an atom can have the same spin. This means that if one electron in an orbital has its spin up, the other electron in that orbital must have its spin down. Alright, let's recap what we've learned so far. The quantum mechanical model of the atom describes electrons as existing in cloud-like regions called orbitals, rather than fixed paths. The principal quantum number, denoted by n, defines the energy level in which an electron resides. Each energy level consists of subshells, which have different shapes, sizes, and orientations. Electron configuration, governed by the Aufbau principle, Pauli exclusion principle, and Hund's rule, determines how electrons are distributed within an atom's energy levels, subshells, and orbitals. And finally, each electron has a spin, either up or down, and no 2 electrons in an atom can have the same spin. Phew! That was a lot to take in, But understanding the quantum mechanical model of the atom is like unlocking a whole new level of chemistry. It provides us with a deeper understanding of how atoms are structured and how electrons behave within them. So, keep exploring, keep learning, and stay curious. Until next time, take care.